Hi guys, so today we are now comparing different types of functions. This school year we've learned how to graph linear functions, quadratic functions, as well as exponential functions. And we're going to talk about how we can identify based on whether we're given a graph, an equation, or a table. Okay, so today we're going to start off nice and easy by identifying given the graph. Okay, and given the equation. Okay. So here we have our three types of functions. We have our linear function, which is our line, our quadratic function, which is our parabola, and then our exponential function. Okay. So linear functions, we have two types. It is either increasing, it's a line going up, or it is decreasing here. With our increasing function, our slope, which we use as m, is positive. For a decreasing function here, our slope is negative. And what we know is that our biggest exponent here is 1. It's x to the first power. With our quadratic functions, which we recently did, okay, they're either positive, which means that they open up, or they are negative, which means they open down. Okay. Our positive quadratic functions have a positive a value, which makes it open up. If it has a negative a value, it opens down. Okay. For quadratic functions, the equation looks like this. And our biggest exponent is 2. And then our last type we have here on our table is our exponential functions. We also have two types. The first one is exponential growth. Okay? And this is when our base is greater than 1. Okay? And then we have exponential decay, and that is when our base is less than 1. In this case, our exponent, linear, is 1, quadratic it's 2. In an exponential function, our exponent is actually our variable. And we see that here where our variable is in that exponent position. Okay. So here we're going to identify our functions given the equations. We're going to classify it just by looking at the exponent, whether it's a number or variable. So we're going to identify if it's linear, quadratic, exponential, or neither, and then we're going to justify it. Okay. So here, my exponent is a variable, okay, and my base here is less than 1. So here, this is exponential decay. Okay. The reason why is exponent is a variable. So that's what makes it an exponential. And the reason why it's a decay is because my base is less than 1. Okay. So this is an exponential decay function. Okay. Next one here, looking at our exponents, the biggest exponent here is a square. It's a 2. So this tells me it is a quadratic. Okay. And the reason why is because the biggest exponent is a 2. Okay. So what type of quadratic is it? Is it positive or negative? It is a positive quadratic. Okay. And the reason for that is because a here is positive. It is a positive 5. Okay. Next one here. Okay, f of x equals 5 plus 7x. So this is a line or a linear function. Okay. The reason why here is because the biggest exponent is 1. This is x to the first power. Okay, and so that's what makes it a linear function. And then what kind of linear function is it? It is increasing because my slope here is positive. It is that positive 7. Okay, so I actually want to highlight this. Okay, so let's look at the next one. Okay, so here my exponent is an x, so that makes it exponential. Okay, the reason why I'm going to just shorten it because exponent is a variable. So that makes it an exponential function. Okay, and then what type of exponential function is it? It's an exponential growth function because that base is greater than 1. Okay, that base here is 3. That base is greater than 1. Okay. Next one here, f of x equals x plus 3 squared minus 4. This is a quadratic. You should recognize it as it is in vertex form. And how I know that is because that biggest exponent is 2 here. Okay. What type of quadratic is it? It is a positive quadratic. And that is because a is positive here. It is a positive 1. Oh no, that's do not highlight the screen. That was a mistake. Actually, let me white it out because I feel like some of you are gonna highlight it. There you go. Okay, so next one here is negative 2x plus 5. Okay, this one is neither technically because it's not even a function. It's not even an equation. There is no equal sign equal to y or f of x. So it is technically neither, okay? But in the thing that we're practicing it, we're going to pretend that it's f of x equals, okay? In that case, this would be a linear function, okay? Although technically it is neither because there's no equal sign. Okay? The reason why is that biggest exponent is 1. Right. It is x to the first power. That makes it a linear function. Okay, what type is it? This is a decreasing linear function. And the reason why is because this slope is negative. Okay, it's a slope of negative 2 where we would go down to right 1. Okay, and so it's a decreasing. Okay, let's flip. Okay. So here, f of x equals x to the 1/2. What we see is that here, it's an exponent of 1/2. Okay, so it is neither 2, 1, or a variable. So this would be neither. Right? Our exponent is 1/2. And what we learned about exponents as 1/2, it's actually a square root. This would actually be known as a square root function. Okay? You will learn more about these when you get into Algebra 2. Okay. And then last one here, we have f of x equals x cubed plus 2x minus 8. Okay, so here my biggest exponent here is a 3. Okay, so this is also neither. Okay, because my biggest exponent is 3. And so this makes it actually a cubic function, right? Which when we learned to classify polynomials, we learned that this was cubic. Okay. Okay, so now we're gonna identify it based on the graph, and then we're also going to go back to key features. Okay, so type of function, this first function here, hopefully we recognize this is a line, and since it's going up to the right, this is increasing, and this is a linear function. So it's an increasing linear function. Okay, the domain here is all real numbers, okay, because here we hit going from the left to right, so left, we hit that arrow, so that's negative infinity, and then as we keep going to the right, we hit that other arrow going towards positive infinity. Okay, our range is also all real numbers, because when we go down, we hit this right here, this lower number, which is negative infinity because of that arrow. And then going up, we hit that arrow again for positive infinity. Okay. Our x-intercept is right here at negative 2, 0. And then our y-intercept is right here at 0, 4. There is no asymptote. Okay. Symmetry, technically we could have a slant symmetry, but we're not going to get into that. We're mostly just dealing with horizontal and vertical symmetry, and since that doesn't happen, not applicable. Okay. Next graph here. This you should recognize as our parabola. This is a quadratic. Since it opens up, this will be a positive quadratic. Okay. Our domain here, it should have arrows, is negative infinity to infinity because of the left side arrow and then the right side arrow. Our range, and we're going up, it hits this number here. This is negative 1, 2, 3, 4. Negative 4 is our lowest number on the y value. It includes it, it touches it, so it's going to be a bracket. And then when we go up, we hit that arrow going towards infinity. Our x-intercepts here, we have two of them. We have one at negative 2, 0 and one at 2, 0. So negative 2, 0 and 2, 0. Our y-intercept is right here. It also happens to be our vertex, which is 0, negative 4. There is no asymptotes for quadratic functions. Okay, so not applicable. And then our symmetry, we do have a symmetry line that is right here down the vertex, and that is our equation x equals 0. Okay. Last one here, what type of function is it? This is an exponential function. Okay. Again, there should be arrows here. Seeing how it's going up and to the right, this is an exponential growth function. The domain, since it's going left and right forever, it's going to be negative infinity to infinity. Range, exponential functions have an asymptote. It's getting closer and closer to this line. If only we saw the grid. It's getting closer and closer to this line here. That is 1. Okay, so not touching 1, but getting closer and closer to it. So it's going to be a parentheses because it doesn't touch it. And then it goes all the way up towards infinity. X-intercept here, it does not have one, okay, because it's not going to cross that y equals 1 line, so it's not going to be going towards here. It's not going to cross it to touch the x-axis. Y-intercept, right here at 0, 2. Okay, asymptote that does exist, okay, it is this line here. And that line is y equals 1. And then symmetry, exponential functions do not have that symmetry. So that's it for today. Have a great rest of the day. Bye, guys.